What is the difference between lengths of 5 metres, 5.0 metres and 5.00 metres? Writing 5.00 metres implies that we have measured the length more precisely than if we write 5 metres. Writing 5.00 metres tells us that the length is accurate to the nearest centimetre. A figure of 5 metres may have been rounded to the nearest metre. The actual length could be anywhere between 4.5 metres and 5.5 metres. The number 5.00 is given to 3 significant figures, or 3s.f. To find the number of significant figures, you must count up the total number of digits, starting at the first non-zero digit, reading from left to right. So let's look at an example. At 3 significant figures, if I write the number 4.62, starting at the left, I count up to the count the digits from left to right. First non-zero digit being 4, so we've got 1, 2, 3 significant figures. If I wanted to write this as 2 significant figures, then I would just write that as 4.6. And if I wanted as 1 significant figure, well, because 6 is greater than 5, I would have to round this up, so this would become just 5. Now if we look at a decimal, such as 0.00501, again I can see that this is 3 significant figures, because I have to count from the first non-zero. So I start counting at the 5, 1, 2 and 3. Again, we're going to write these out now into 2 significant figures, so this would now become 0.0050. And again, if I want to go to 1, then I just write this as 0.005. And I could have numbers written in standard form or scientific notation. So at 3 significant figures, I could be 3.40 times 10 to the 8. Now if I wanted to write this into 2 significant figures, this just becomes 3.4 times 10 to the 8. Didn't realise I missed the 8 off there. And if I drop this down to 1 significant figure, we get to 3 times 10 to the 8. And in this final example, I'm going to choose the number 169. Now, when I write this into 2 significant figures, I'm going to have to go to standard form. So that would come 1.7 times 10 to the 2. And if I wanted to write this as 1 significant figure, this has to become 2 times 10 to the 2. Why are we writing it in standard form? Well, if I wrote the 1.7 times 10 to the 2 as 170, well, from this, if you just see it as 170, well, this could be 2 significant figures, or it could actually generally be 3 significant figures. I can't distinguish between the 2. So, if I write it in standard form as 1.7 times 10 to the 2, then this clearly shows that it is to 2 significant figures. So now we're going to have a look at how many significant figures you should use, or should give your answer to when we perform calculations. This depends on the precision of the numbers you use in the calculation. Your answers cannot be any more precise than the data you use. This means that you should round your answer to the same number of significant figures as those used in the calculation. If some of the figures are given less precisely than others, then round up to the lowest number of significant figures. We're going to use this swimmer as an example of that. So the swimmer in the photograph covers a distance of 100.0 metres in 68 seconds. We're going to calculate his average speed. Okay, so speed is equal to distance divided by the time. Well, he's travelled a distance of 100.0 0.0 metres, and he's done it in a time of 68 seconds, and if you put that into your calculator, it will come out with an answer of 1.47058882 metres per second. However, this is an answer that's for far too many significant figures for the precision of the measurements taken. So if we look, well, the measurement of the distance was to 4 significant figures, but the time is only to 2 significant figures. So therefore, because we're not very precise in the time, we should only give our answer also to 2 significant figures. So if we then write this, our answer should be 1.5 metres per second.